noise like thunder. The rocket takes off for space. But how do we know what it's going to do? The second our rocket is out of view, with a great big noise like thunder, the rocket takes off for space. It travels so fast that it can't be seen, so we have to track it on a radar screen.
There'll be movie cameras to film the rocket flight.
There'll be TV cameras right at the launching site. There'll be men to tell us our rocket has hurled a man-made moon that will spin and spin all around the world. With a great big noise like thunder, our rocket takes off for space. With a roar like a fire as it climbs ever high. With a great big noise like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Rocket ready for flight. Prepare for launching of satellite. Man's first step into outer space.
We're in the blockhouse, a short distance from the launching pad of the rocket. The blockhouse has concrete walls, heavy walls 10 feet thick, and a roof with reinforced concrete 27 feet thick. A few minutes ago, there was a cloud of red smoke over the blockhouse. This meant that only 20 minutes were left, and radar operators checked their electric wires just once more, as they had done many times before. Everything has been checked and rechecked so many times. Fuel, valves, electrical wiring, tracking cameras, all must be in perfect working order. In 1/2 hour from the firing, our man-made moon will be 700 miles from the launching pad and will begin to circle the Earth at an altitude of 200 miles above sea level. There's someone going to the blackboard. He writes T minus 15. That means there are just 15 seconds remaining before our rocket is fired and goes soaring into space.
10, 9, 8, 7.
Through the loudspeaker, we hear the seconds being counted off.
3, 2, 1, 0. Fire!
Is rising, slowly, slowly, balancing itself on its own exhaust blast. Now it's X plus 15 seconds, and our rocket looks like a huge silver pencil growing smaller in the sky. In the blockhouse, every man's eye is glued to the panel, watching dials and graphs that trace the rocket's flight.
Time X plus 90.
1.5 minutes since firing. In another minute, there will be no more fuel in the first stage of our rocket. It will have used up the liquid oxygen and special fuel mixture that has given our rocket its tremendous power.
Radar report, Grand Bahama. We have the rocket on our scope.
Good. Everything is going according to plan. Wait, is that a dot on our radar screen? It's growing longer. Now there are 2 dots.
Separation accomplished. Second stage in acceleration now.
The first stage of the rocket has dropped off. Soon the first stage will begin falling while the second stage carries on.
Impact computer states first stage will impact somewhere beyond Grand Bahama and will fall into the sea. Altitude over 40 miles.
The second stage of our rocket is filled with nitric acid and fuel. This gives us a powerful thrust when the motor catches fire and shoots out tremendous flames. Of course, we can't see the rocket, but we know what's happening because our radar stations down the range are reporting into us the minute that important dot appears on their radar screens.
White Sands Proving Ground, New Mexico. We've just picked up the rocket on our screen. Second stage separation accomplished.
9 minutes have gone by since the liftoff. The second stage will soon go spinning into the ocean, and our third stage will fire. It will burn for less than 60 seconds, but that's all it will need. Our speed is increasing at a very fast rate now. 10,000 miles per hour, 12,000 miles per hour. Now it's 14,000 miles per hour.
Computer reading. Third stage now at burnout. Velocity almost 4.8 miles per second.
That means our rocket is now traveling at 17,000 miles per hour. And only one more separation is needed to put the satellite into its orbit around the Earth. Now the third stage of the rocket holds the satellite, a 20-inch shell-shaped container with a thin plating of gold. Inside the shell are many tiny instruments busily at work as they record important information. And all the while, our satellite will spin around the Earth, making its journey around the world once every 90 minutes. Think of that. People all over the globe, not only in New Mexico and in Florida, will see it, but people in Spain and in India and in Tokyo, Japan. They'll see the satellite too. And all the while, the little gold ball with cameras and instruments inside will be taking pictures and measuring the weather in space, the radiation, and the millions of things that scientists have to know before it would be safe to send a man into outer space. Just a minute. I think we've got another report on the radio.
Australia tracking station. We picked up your satellite, America. Jolly good show.
Instruction number 3 to follow the American.
Our satellite is expected to orbit the Earth for a few weeks. It will carry a retro rocket to break it out of its orbit, and at a certain height will parachute slowly to Earth. In this way, we will recover the satellite and gain valuable information which the cameras in space have been keeping for us. The important pictures that will tell us more and more about outer space. Our engineers and scientists will study these pictures before man's next flight. And there'll be many more satellites shot into orbit around the Earth, man-made moons that prepare the way for man's future journey into space.
There'll be movie cameras to film the rocket flight.
There'll be TV cameras right at the launching site. There'll be men to tell us our rocket has hurled a man-made moon that will spin and spin all around the world with a great big noise like thunder. Our rocket takes off for space with a roar like a fire as it climbs ever higher with a great big noise like
10, 9, 8, 7, 6, 5, 4,